Hello everyone. For today's lesson is about inverse variation involving equations, tables, and graphs. And here are the learning targets. I can identify and describe situations that show an inverse variation, and I can identify the y, x, and k are the constant of variation and represent inverse variation relationships through tables, equations, and graphs. To define inverse variation, it is a relationship where one quantity increases while the other decreases and vice versa. And to write the equation form of this is y equals k over x. This is read as y varies inversely as x, or you could also read this as y is inversely proportional to x. And the same thing with other variations. Our k here, again, is our constant. Now, based on our definition here, one quantity increases while the other decreases, and vice versa. That means if y goes up, our x here goes down. Similar thing with y goes down, that means our x goes up. Now let's have some real-life connections of inverse variation. For example, we have here eating food. So the more people eat from one dish, that means the less food remains. So let's have people as P and dish. So base here, we could say that as more people eat from one dish, then that means the food or the dish, or let's just change TSF. The less food there will be. Another thing we could also have with work and time. Work and time. So the more workers you have, then that means the less time it takes to finish a task. So if we have more workers, then obviously the time would go down. Another thing with speed, speed and time travel. Speed and time travel. So let's have here our speed. So the faster you drive, then that means the less time it takes to reach a destination. So the faster the speed for the car is, that means it will take a shorter time for you to travel, which basically is logical. Again, as for speed and time travel, we just have T here, and then another thing, let's have light and distance. So for light and distance, the farther you move from a light source, that means the dimmer it becomes. And I think that is pretty understandable. So base here, we have light. Okay, so the farther, so let's take farther as going up. And then obviously, the dimmer it becomes. So let's have dim as a negative thing, so which goes down. So down. Where's the blue? Yeah, and that's it for some real-life connections of inverse variation. This time, let's solve for the constant. If y is 8 when x is 3, find the constant. So based on this, based on our equation form of the equation, so y equals k over x. So y is 8 equals k, which is the thing that we're looking for, over 3. All you need to do is to do cross multiplication. Again, 8 here as a rational number is also a fraction, which means we have 8 divided by 1, an invisible 1, because obviously 8 divided by 1 is just 8. So again, all you need to do is to cross multiply. Okay? Or you could just directly have it as 8 times 3 equals k. And 8 times 3 is 24. That means this is the value of our constant. This is what we are looking for. Now, just to prove if k is actually correct, again, our given here, our y is 8, our x is 3, and our k is 24. So if we let k again be 24 and x as 3, so 24 divided by 3 is 8. So that means our process and solution here are correct. So another thing with this, since we know that the value of k is 24, we can now write our equation. So for our equation, it is written as y equals, the value of k is 24, so 24 over x. Another problem, given y equals 24x over x, find y when x is 6. So based on this, we could just directly substitute the value of x here, which is 6. So you could just do it right away. 24 over 6 is equal to 4. Next is, let's try to find the value of x. So given here, if y is equal to 36 over x and y is equal to 9, find x. So we have here the value of y is 9, so we could just have it this way, 9 equals 36 over x. Again, all we need to do is to do the cross multiplication. So 9 times x is 9x, and we have here 36 and an invisible 1. So 9 times x is 9x equals 36, and divide both sides by 9, because again, the coefficient that we need for any variable, if we're looking for the value of certain variable, should always be 1. So 9 divided by 9 is 1, so we're left with x equals 36 divided by 9 is 4. And this is the value of x. Now, if you are to construct a table of values, so constructing a table of values. So if our equation here, we have equation y equals 12 over x. So we have here, let's create a table first. So you have here how many numbers? Let's try 5. So 1, 2, 3, 4, 5. And okay, so let's have this as our x and as our y. So for our x, we're just gonna have numbers 1, 2, 3, 4, and 5. Again, all we need to do with this is to substitute each value to x. So we let y be 12 divided by 1, because that is our first number here, as you can see. So obviously 12 divided by 1 is 12. So let's write 12 here. So next, let y be 2. Let x be 2. So 12 divided by 2 is 6. So 6, y equals 12 over 3. So 12 divided by 3 is 4. So 4, and let x be 4. So 12 divided by 4 is 3. And last one, if we have y, or if we let x be 5, so we have 12 divided by 5 is equal to 2.4. So 2.4. As you can see here, just like from the definition of inverse variation, if one quantity goes up, the other goes down. So base here, the values of x are going up from 1, 2, 3, 4, 5, and obviously the values of y are going down from 12 to 2.4. So that's how an inverse variation works. So without a certain equation or without using a calculator, if you are given just a table of values, we can directly say that that the given table is an inverse variation if the values of x are going up and the values of y are going down, or vice versa. Now let's continue in solving for missing values. So if x is 4 when y is equal to 9, find y when x is equal to 6. We have our first part here. We have our first part here and our second part. So before we do the second part, let's have the first part. So again, our form is y equals k over x. The value of y here is 9. The value of k is still missing, so we need to find that first as an essential number for us to compute or solve the second part. And the value of x is 4. So again, all we need to do is to cross multiply. So we have here 9 and 4 and k times 1. So 9 times 4 is 36, and that is the value of our constant. So we know that the value of k is 36. The y here in the second part is missing, and the value of the new x is 6. So we can write it like this. So y equals 36 times 6. And 36 times 6, sorry, this is direct, sorry. So 36 over 6, that means the value of y is 6. And here is the value of what we are looking for based on the given problem. Another thing, let's have a given in which x is 5 and y is 10. And our task is to find the equation. So all you need to do is to use the form of y equals k over x. So the value of y is 10 and the value of k is still missing, and over 5. Again, cross multiply, so 10 times 5 is 50 equals k, or the constant, and this is our k. So based on our form, which is this one, we could just substitute the value of k, or constant, to this one. So y equals 50 over x, and this is our equation. Let's have another problem here. We have y. If y is 5 when x is equal to 9, This time, find, in the second part, find x when y is 15. So form y equals k over x. So first you need to find a constant in order for us to solve for the second part. So y here is 5 is equal to k over 9. Cross multiplication, so 9 times 5 is 45 equals k. So this is our constant, and when we write this into an equation, so we have y equals 45 over x. And based on our equation here, we could now derive the second part of the problem in finding the value of x. Since the new y here is 15, so we could write 15 is equal to 45 over x. So cross multiply still, so 15 times x is 15x equals 45. And then divide both sides by 15 so that our coefficient should just be 1. So cancel, cancel. We are left with x, and 45 divided by 15 is 3. And this is the value of our x. Now let's have an example in which we are looking for the equation given a table of values for x and y. So all we need to do with this is to just write first the form, so y equals k over x, and recognize that we have pairs here. We have pair 1 here for 1 and 50, second pair 2 and 25, 3 and 16.6, repeating, 4 and 12.5, and 5 and 10. Again, we are sure that this is an inverse relation by just looking at it, because again, the value of x, as you can see here, from 1 to 5 is going up, and the values of y are going down from 50 to 10. So yeah. Now going back to solving. So you could just choose any of the pairs. It could be from 1 and 50 to 5 and 10. You could just stick to 1 and 50, but let me just try 5 and 10 here. So my value of y is 10, and my value of x is 5. So anyway, we have our k here, which is still missing. So cross multiplication of 10 and 5, cross multiplying them is 50, and k, this is the value of our constant. Now based on this, by having the form, we could just directly substitute the value of k. So y equals 50 over x, and this is our equation. But just to check if this one here is really correct, so let x be 1, so 50 over 1 or divided by 1 is 50. Let x be 2, so 50 divided by 2 is 25. And we have y equals 50, and let x be 3, so 50 divided by 3 is equal to 16 point repeating of 6. And we also have y equals 50 divided by, let x be 4, so that's what we got 12.5. And lastly, obviously based on the given, so we have y equals 50 divided by 5 is 10. So since our numbers here coincide with the table, so that means our equation y equals 50 over x is correct. Lastly, let's gonna talk about the graphs involving inverse relation. Before we go to inverse relation, let's have direct relation first. So if our given equation here for direct relation, kx, so let's have the constant as 2, so 2x. Based on this, let's have a table for this one. One, two, three, four. Okay. let's have x, y. So 1, 1, 2, 3, 4, 5. So if we let x be 1, so 2 times 1 is obviously 2. And if we let x be 2, we have 4. So 6. So the pattern goes on. So 2, 4, 6, 8, 10. Now let's create or draw a graph first with regard to direct variation so that we can differentiate on how it looks on both ends. So here. Okay, so I'm just gonna use what do you call this? I'm just gonna use the quadrant 1 since both our values here are positive. Okay. Okay, so we have here for the x 1, 2, 3, 4, 5. And for the y, I'm just gonna have this in the interval of 2. So 2, 4, 6, 8, 10, 12. Okay, so first let's have 1 and 2 as our first pair. As our first pair here, we have 1 and 2. So 1, 2. Next we have, wait, let's have a different color. We have 1, 2. Next we have 2, 4. Next 3, 6. Then 4, 8. And where am I? 4, 8. And 5, 10. So as you can see, our line is just linear. Sorry, not perfect, but you get the point. It's just linear. Now, yeah, that's it. Now, let's have, this is a graph of, again, a direct variation. So just to make it clear, again, our goal here now is to differentiate on what a direct variation versus an inverse variation comes to graphing. Direct variation. Now let's have an inverse. Or we could just use, we could just use this one perhaps, or let's just use a different or smaller number. So graphing an inverse variation. So let's have our equation y equals, let's choose 10 for just a small number of 10 over x. So let's have a table of values for this. One, two, three, 1, 2, 3, 4, 5. Before I forget, again, for direct variation, it is linear. Okay. We have here x, y. So let's have 1, 2, 3, 4, 5. Now, if we let x be 1, so the result is 10. If we let x be 2, the result is 5. And if we let x be 3, so we have 3.3 repeating. And we have, if we let x be 4, so we have 2.5. And if we let x be 5, so we have 2. Let's encircle these first. So 10, 5, 3.3 repeating, 2.5, and 2. Going back, we have pairs. 1, 10, 2, 3, 4, 5. for 2, we have 5. Next is 3.3 repeating, 2.5, and 2. So based on this, actually we could still use 0 and other numbers going to the negative side, but based on this, let's just try this. Okay. One, two, three, 4, 5, 6, 7. This one, let's have 1, 2, 3, 4, 5, 6, 7, 8. Let's add more. 9 and 10. So based on this, we have 1, 10, 2, 5. Wait, 2, 5. 3 and 3.3, so perhaps it's on this location. We have next 4 and 2.5, and if we have 5 is 2. So based on this, we can conclude that if we are going to graph, what do you call this, an inverse variation, it is hyperbolic. Although this is not that clear based on this illustration, so it would actually look, for example, if this is our Cartesian plane, it would look like this. So yeah, although it's not the usual up and down or side and side hyperbolas, but yes, it is showing a hyperbolic image. So just to see if it really does, then let's try using Desmos for this. Now we are now in Desmos, and just like from our equation, so we have y equals our k was 10, 10 over x. So just like from earlier, so if you have 1 here, so as you can see, we have 1, then 1 and 10, obviously 1 and 10, yeah, that's it. Next, if we have 2, so 2, I can wait, 2 and 5. So yeah, again, if you try to zoom out, as you can see, if you just want to tilt it a little bit, then it's actually hyperbolic. So that is the difference between an inverse variation compared to a direct variation. So for inverse, this one here is hyperbolic. Whereas for a direct variation, base here, it is linear. And that's it for today's lesson. I hope you learned something.